Hey, hello there. So today is day 10 of the May Leetcoding Challenge questions. So far the question has largely remained to be easy, but tomorrow we're getting into the 11th day, so into the middle of the month. Hopefully tomorrow we can have something that's a little bit more challenging. Today is still a relatively easy question. It's called Find the Town Judge. So we have n different people labeled from 1 to n, and there is a rumor one of these people is a town judge. The judge has these properties as follows. The judge trusts nobody. Everybody except for the town judge trusts him or her. And there is exactly one person that satisfies these two properties, if there is one. So if there is one, we should return the integer number that can identify him or her. Otherwise, it's a negative one. Will be given to us the array of tuples, which means person A trusts the person B. So that's the input. So if we think about this as a graph, everybody here is a node. So we have n different nodes here. This property basically translates to there is no outgoing edges from the town judge. And this second sentence translates into the town judge node has n-1 incoming edges. So if we just process this array to populate the statistics about the number of incoming and outgoing edges for every node, we can just do a simple query for just to see from 1 to n which person have satisfied these two properties. And then we can just return that if we can find one. Otherwise, we return -1. So in terms of time, it will be the amount of time to process all the edges, and also just to go through all the nodes to check these two properties. So it's a number of edge plus number of nodes. And in terms of space, we are storing the incoming and outgoing edges, number of those things. So it's 2 multiplied by number of nodes, number of persons. So it's 2n. So that's the time and space analysis. I don't think it's for this question this simple. It's not necessary to go through some of the examples. Just for the sake of verifying what's going on, let's actually just take a look at one. So here, what we're gonna calculate is the incoming edges. For person 1, it's 0 actually, and the outgoing edges for person 1 is we have 1, 3, 1, 4, so that's 2 for the person 1. For person 2, the incoming edges are 0 as well, and the outgoing edge from person 2 is 2, 4, 2, 3, so it's 2. For person 3, the incoming edge is 1, 3, that's 1, 2, 3, 2, 4, 3, that's 3, and the outgoing edge from person 3 is 0. For person 4, the incoming edge, we have 1, 4 and 2, 4, so it's 2. Outgoing edge, it trusts the person 3, so it's 1 there. So then we just looking at the person by person, we find the judge should be the one that trusts nobody. So I equal to 0, and in edge, just call it judge, should be n-1. So we find this is the person here. This is person 1, person 2, person 3, person 4. So this is just a detailed walkthrough about the example. We're populating the in edge and out edge and just check person by person to find the person that contains 0 out edge and n-1 incoming edge, and that's the judge. So that's pretty much the solution. So we're just going to translate the above example process into the code. So we for the incoming edge, we increment the person that's being pointed to, and the outcoming edge for the person that the edge is originating, we increment that as well. And after this for loop, we process all the edges inside this trust array. Then we check from person to person. So the criterion is that if this person has no outcoming edge and it has n-1 incoming edge, so the person except for himself trusted him and he trusted no one. Otherwise, we're just gonna return -1. So this should be the code solving this question. And I guess a little bit optimizing can be done here is that so this can be translated to simplify a little bit to be the difference between incoming edge and outcoming edge to be the difference has to be n-1. So this should work as well, because you're testing the two equality with the AND. That's equivalent to take the difference and from both sides. The in edge person subtract outcoming out edge person should be equal to n-1 subtract to 0. Just basically rearranging terms in this mathematical equations here. So it should be equivalent. And then we realize that another optimization we can do is to just consolidate this two hash map into one. Or if you use array of size n, that's you can consolidate a two array into one as well. I'm gonna just call this trusts, and it's gonna be. Let me just use m multiplied by m plus 1, use array as well, use an array instead of the hash maps. What we have here is going to be the in edge is only is subtracting the out edge, so instead of having two things to keep track of those, for the in the two, we just increment that, and the from we just decrement. And so instead of in the end we calculate the difference, it's kind of effectively already be calculated during this for loops here, so that we can actually reduce the space requirement from 2n into just the n. So if trusts person, that has to be equal to n-1 as usual as here, we can return the person. So that's the space optimized solution. It should work as well, I hope. Yeah, it's indeed. So there's really nothing special about this space reduction. You can observe that by analysis about this final testing condition. You have two equality there. If you just rearranging terms, you can get this, and you can realize instead of do this final subtraction in the end, we can just consolidate those two into one, either hash map or array, and just do the smaller increment, smaller updates during the graph processing part. Yeah, when we do the person lookup, we can just by directly testing this final quantity there. So that's a little bit optimization on space, but the time is still the same. The space, you drop the constant multiplier, but it's still linear. So that's the question. All right.